Greetings, Earthlings. What you see here is a vintage Weston panel meter that I got off of eBay several years ago. I saw it on there and said, well, that's just too cool not to have. And so it sat around for a few years, and then I said, well, that's just too cool not to use in something. So I turned it into something which we'll see here. But you see, it's a proper meter, mirrored scale. I don't know if you can see this, but 50 microamps full scale. Even though it reads 0 to 100, that's actually plus 50 microamps, and that's minus 50 microamps. So I built a Null Meter. You can see that there. It's battery powered. It takes batteries there. Oh, and I'll get to that. What's a Null Meter, you say? Maybe. Well, right, so what's a Null Meter, right? Yeah, it's a voltmeter, which can read very low voltage levels. This goes down to 10 microvolts full scale and up to 1,000 volts full scale, although I would not take it over 300 volts because the parts internally, actually, some of them are rated for maybe 1,200 volts, but I wouldn't try it. I don't need 1,000 volts. Low battery indicator, by the way. So it will read directly on the scale here voltage, DC voltage. Okay, if I'm on a 100 millivolt scale, that would be 0 to 100 millivolts, 0 to negative 100 millivolts. But because it has the center 0, it's useful for lots of stuff that maybe your digital meter isn't so good at. So let me turn it on. First thing we'll do, turn it on. I'm on a 100 millivolt scale, but okay, notice it's out. It has a 0. Oh, you know what? Let's get it to true 0. That's what the shorting bar is for. Okay, except I'm turning it the wrong way. Okay. If I put the shorting bar on there, then it really and truly is 0 volts in. Okay, and you can see there's some offset there. This adjusts the offset. And that's pretty close to 0. Okay, now we go back. Well, let's talk about how we got to this point. So I had this meter, and I decided I'm going to build a Null Meter out of it, and I found an article, series of articles actually by Conrad Hoffman, written in I think 1996, called Mini Metrology Lab. Was a series of articles. So he had three things that he designed and published in these articles. First was a voltage reference. Well, I've got a voltage reference here. Second was a Null Meter, and the third was a Kelvin-Varley divider. Okay, so I said, oh well, I'll just use his design. Only he designed it to output to a digital meter, and I had this analog meter. So I made some changes to his design. Took some liberties, shall we say, but it's based on that. And I mean, it's a simple enough circuit anyway. There's on the input side, there's a divider, and then some protective circuitry going into a precision amplifier, and then there's a switchable multiplier here. Ultimately, and then I have a buffer, which he didn't have because I'm using an analog meter. Ultimately, the output is 100 millivolts full scale. I did a previous video on how you can take an analog meter, arbitrary analog meter, and get it to output, turn it into a voltmeter with whatever range you want. So I did that here with hand-selected resistors to get this to read. On the 100 millivolt scale, it's basically a pass-through. The divider is dividing, well, it's not dividing, it's dividing by 1, if you will. And the multiplier, the multiplier is multiplying by 1. It's just buffering it. So on the 100 millivolt scale, and I set that to 1 volt, okay, we should be able to go 100 millivolts and see that it reads pretty close to full scale. Pretty close for, that's good enough for an analog meter. Ultimately, this is not what you're going to use it for. And because of that, I'm not too concerned that on the 1 volt scale, it doesn't really read 1 volt. Okay, apparently the input impedance of that amplifier, the op amp, is not as infinite as I would have liked it to have been. This is fixable. It would require just increasing the gain on that setting. However, if you look at the PC board, what I did is basically I'd have to cut the trace that's between these 2 pins here. There's a switch mounted on here. That's this switch. It's like a $20 switch. And the trace is there, which is currently covered by the switch. There's no way I'm going to be able to desolder that switch. So I'm not going to worry about it. But the fix would be to cut the trace that's between those 2 pins and put a resistor in there, about 22 ohms or something. And that'll get us back to full scale on 1 volt. But we don't need that. We don't need to be too concerned. Okay. So here we are on 10 volt scale. You can see it reads 1 volt there pretty good. I can go put it up to 10 volts there. And it reads pretty close to 10 volts. Go to the 100 volt scale. There's 100 volts. Again, reading pretty close. And I'll go to 1000 volt scale. And I'll take it up to 300 volts, and you can see that. It's 300 volts. And I'm not going to go any higher than that. Okay. So back to the 100 millivolt scale. More interesting is these lower ranges, okay? We can go to 10 millivolt scale. There's 10 millivolts. We can go to 1 millivolt scale. There's 1 millivolt. We can go to the 100 microvolt scale. There's 100 microvolts. And 10 microvolt scale. Oh, wait. Here's a problem. This thing has an output offset. It's all set to 0. And I zeroed this meter with the shorting bar. So this is reading 3 point something microvolts when it's set to 0, which is slightly out of spec. It should be no more than 2. On the 100 volt scale, also no more than 2. And it's a little better there. But I can zero that out. I can take that out. Okay. I mean, that's close enough from where I'm sitting. And you'll see it does move slightly. It wavers. I don't know. I can probably cause it to move just by waving my hand over it or touching it or whatever. Okay, so 10 microvolt scale. Wait, that's 1 microvolt. Look at that. That's 1 microvolt it's reading. So it can actually indicate each of these ticks on this scale is 400 nanovolts. There's 10 microvolts. But 1 microvolt, 2 microvolts, 3. So it can easily distinguish to a microvolt level a difference. That's cool, and so that's one indication of what it's good for is like for calibrating this thing. There's an adjustment. There's a 0 adjustment on this, and so for actually getting that within spec, this is a very handy meter. Probably better than a digital multimeter. but it has another mode. And I'm going to switch off. You see this little switch over here. It says null or diff. It's got a differential voltmeter mode. And that's what those jacks on the back are for. So I am going to connect my adjustable voltage source to the back. Okay. And that's at 0, 0, 0, 0. I'm going to go back and zero it out again. We'll zero it out. Okay, power back on. We'll zero it out for this mode. Yeah, right around there. Okay. And now, what do we do with this? Well, this is 1, 2, 3, 4, 5, 6, 7.5 digits. I now have a 7.5 digit voltmeter. And to see how that works, we'll take a mystery voltage right here, and we'll connect that. And it's well below 1,000 volts. There's something there. And on the 10 volt scale, it looks to be about 4 volts. So I'm on the 10 volt scale. Let me put it to 4. And that's good. Okay, bring it down. You know, that's looks to be, from where I sit, a little under 0.1 volts. I could go 0.1. Hard to tell anything from that. Yeah, it's a little under 0.1. Oh, this is the 0.1. Okay. 0.1 overshoots. Okay, so it's under 0.1. So I'll bring that back down to 0. Okay, that's 0.9 and back to 0.1, so it's somewhere between 4.09 and 4.1. Okay. But how far? Well, it looks like 6 something. 4.096. Bring that down to within 0.1 and go to the next scale. That looks like 0.3 something. So 0.3, and then again 0.4 is too much. Okay, 3. And that looks like about 0.6 something. So there's 6. 7 takes it over. And down there, and that looks like about 0.4-ish, 3 or 4. There's 3. There's 4. I'll call it 0.4. Whoops, no, I won't. It's somewhere in there, between 0.3 and 0.4. Okay, we can call it 0.4. 4.096364. Okay. Now, what is it? I have a digital voltmeter connected. So what does that read? Okay, there's the Tektronix 5.5 digit 4.0966, 4.096364. They agree within a couple of counts of this thing. This does not. If I take the inputs and short them together, it will not read 0. So this is going to be off a little bit in the last digit. So which one are you going to believe? The digital, fancy digital, or the good old-fashioned analog? Well, I think my money would be on the analog one. There, see, with these shorted together, I'm getting 0.0003 or whatever. If I go relative and go back to my voltage reference, now what do I read? 4.0963. 4.096363. Okay, so there you have it. They're pretty much bang on. They pretty much agree absolutely, completely.